Hello, this is Charan. This is regarding Big Data Analytics and Application Assignment icp7, and the challenge is to run k-means cluster against the 5 clusters and use a different data set and then present the results in terms of visualization as well. So I've taken a data set that is about the credit card fraud classification fraud from the Kaggle dataset, and I've removed a few. Since this is not allowed, the size is 144 MB is not allowed in the GitHub submissions. I pushed this into Google Drive and had run this one. So here is the dataset, and I also gave this link here just in case. So this is a link. Going down, here is what I am reading, and here I've read the data frame in terms of CSV file, and also I dropped the categorical variable class. Categorical variable are not good in terms of Euclidean distance because categorical variable represent the name, the record, not a quantitative measure. So since it's not a quantitative measure, when used against the Euclidean distance, that will fail badly. So that's where I've not used that. Here are the few examples, and I've scaled down for the standard scaling procedure, and I've already ran this, and it's currently as well running, as we can see here, and this is running currently. So what happens with this k-means cluster? There's several variations of clusters I've shown, and I've also used siloed score to measure the accuracy of this clustering. So I've taken two approaches at the time of visualization, and also to explain these two approaches, here are the few questions I had and which I tried to solve as part of this assignment. The first one is, how do we represent a two-dimensional graph when we have multiple features of around 30 in this very example? So one way of solving this is reducing the 30 dimensions to 2 dimensions using a principal component analysis, PCA based analysis. So there are two ways I try to solve the problem. First one is use the k-means cluster to predict all the 30 columns, and the predictions and 30 columns is then reduced to 2 columns, and then that's represented on the graph. That's approach number 1. Approach number 2, I've used the 30 column features reduced to 2 PCA features, and these 2 PCA features are now fed to the k-means clustering and predicting the clusters. And based on these k-means clusters, I've reported the results for approach 2. On the conclusions perspective, I could see the sellout score has been greater for the PCA based prediction rather than the normal predictions. As we can see here, this is about a 0.089, and this is about 0.4147, which is using the PCA based features. And I've taken examples of starting with cluster 7. As we can see, here is a cluster 7, and this is a graph. This is a non-PCA features predicted using k-means, and then the features are reduced to 2 PCA features and then presented on the graph. But this, as we can see, is a PCA features and then is fed to the k-means clustering, and once clustered, I've shown that in the clusters. As we can see, PCA based clustering has shown better promising performances, as it was able to clearly identify the clusters without much overlap. And here we could see a lot of overlap. Speaking of the results, here are for clusters 7 to 11, and speaking of the results, as we can see here, I've used 7 to 11 clusters based on the elbow graph. The elbow graph, since I have run that, it's at the time of writing the elbow graph. So looking at the elbow graph, I've decided 7, 8, 9, 10, and 11 are the best clusters that we could use. Since based on these clusters, I could see the best performance is PCA based features for cluster 8. So here are some conclusions where PCA reduced features are giving better results in terms of select score and measure for better clustering. The second observation is that PCA results are showing visually better clustering than the um, all-in features, all-in features for all-in 30 features for the clustering. And the third feature, k-means clustering has proven bad for categorical variables. Since k-means cluster uses Euclidean distance, these categorical variables will is not actually a quantitative measure of the record, but it's more of a unique identified type of a record. So I have to drop the categorical variable based on this and has represented that in the graph. As we can see, the code isn't run right now, but I can show the elbow graph that's generated out of the report. As you can see, this is an elbow graph that's generated. Thank you.